The other end of the string hangs a 2 kilogram mass. So the plane is frictionless, so is the pulley. Determine the acceleration of the blocks. No? So we have here the assumption that the 2 kilogram block will be accelerating downward, while the 3 kilogram block will be accelerating up the incline. So we don't know whether it's really the direction of motion, no? Because it is possible that the 3 kilogram mass will be sliding down, while the 2 kilogram mass will be accelerating up. Okay. So anyway, it will show in our computations whether our assumption is correct or not. Okay, so who would like to work on this? May I have a volunteer? Newton's second law. F is equal to ma, or the summation of forces equal to ma. Any volunteer? Any volunteer?
Sir, ano po ulit yung value ng mga mass po natin?
Come again?
Sir, ano po ulit yung value ng mga mass po natin? Medyo di
3
ko po
and
kasi makita. 3 and
3.
2 po. Sige po.
Who would like to solve this? So let me begin. Let me isolate the 3 kilogram mass. First, we have the weight W, and it has components parallel and perpendicular to the plane. All right. But we assume that motion is up the incline. We assume that the 2 kilogram block will go down, so the 3 kilogram mass will slide up at an acceleration, a known acceleration. And of course, we have the tension T in the string. So applying Newton's second law to, let me just call it as block 1 and the other as block 2. So for block 1, we apply Newton's second law. Movement is up the incline, so tension minus the opposing force is Wx, equal to the mass of block 1 times the common acceleration A. So tension minus Wx is W sine of 40 degrees. Okay, so we know that this angle, that angle is 40 degrees also. So W sine 40 equal to the mass, 3 kilograms, times the unknown acceleration. But the weight W is M times G. So the mass is 3 times 9.8 times sine of 40 degrees equal to 3A. Or T minus 29.4. 3 times 9.8 is 29.4. Sine of 40 equal to 3A. So let us refer to this as equation 1. We now go to block 2. So for block 2, we have, of course, the weight. But we know that it is going up. Let us call it as W2, and the acceleration is direct. Oh, sorry. It is directed downward. That is our assumption. And then, of course, it is connected to the same string with a tension T. So for block 2, Newton's second law, summation of forces equal to MA. Since it is going down, weight 2 going down minus the opposing force T is equal to the mass of block 2 times A. And what is W2? W2 is mass 2 times G. So that is 2 times 9.8 minus the tension T, which is ano, equal to the mass 2 of 2 times the acceleration A. This is equal to 19.6 minus T equal to 2A. Okay? And we shall call this as equation 2. And as you can see, we can eliminate T by adding equations 1 and 2. So T minus 29.4 sine of 40, then plus we add the left side of 2, 19.6 minus T equal to, we add the right sides, 3A and 2A. So as you can see, T will cancel. The right side is 5A. So negative 29.4 sine of 40 plus 19.6. From this, we can calculate for the acceleration. And what did you get? What will be the acceleration? What is the acceleration?
0.14, sir.
0.14 unit meters per second squared. So indeed, in this setup, block of mass 2 kilograms will accelerate down at 0.14 meters per second squared, and the same acceleration for the 3 kilogram mass, but up the incline. So what do you think will happen if I'm going to increase the mass of block 1 to say 4 kilograms? If it is 4 kilograms, what do you think will happen? Any idea on what will happen if I'm changing the mass of block 1 to 4 kilograms?
Mag-iiba siya rin yung direction, sir.
So, paano ngayon? Mag-slide pababa yung block 1. So, mag-slide siya pababa. Doon ang direction ng kanyang acceleration. So the 2 kilogram mass will be moving up. No? Will be moving up at that same acceleration, whatever that acceleration is. Okay? Any questions? Okay. So say, for example, each of these weighs 500 kilograms. What force is required to have an acceleration of 0.20 meters per second squared? Say, for example, that the frictional force, the drag, let us say that the drag on each car, the drag is 0.04 of the weight. Then determine also the tension between, well, this is 1, 2, and 3. Find tension in the cable between 1 and 2 and 2 and 3. Okay? So meron daw drag. Well, this is F2, F3. So dito, let us say that wala na, no? Walang drag dito sa car 1. How do we find the force F that will produce that indicated acceleration of 0.20? I think mas maganda na lalagyan nga natin din ng drag tong na to. And let us say that that is also 500 kilograms. Para kompleto na. Ayan. Okay? So each car has a mass of 500 kilograms and there is a drag or friction, no, between the rails and the track for each car in the train. How do we solve for F as well as the tensions? Anyone? Any volunteer? Any idea how to solve this? Any suggestion kung paano natin gagawin? Meron ba akong kausap dito?
Newton second law, sir.
Oo nga. Yun naman topic natin, Newton second law. So, saan natin sisimulan yan? Motion is along x, no? Kung ito ang ating x direction. Ito yung ating x. So, motion is along x. Ano meron dyan? Yung F. Ano yung magpo-produce ng acceleration? Dapat yung F, ano? Pero, meron kang opposition. Meron kang drag. F1, F2, and F3. So the force to the right minus the opposing forces, F1, F2, and F3 must equal the total mass times the acceleration. Ano lang kasimple yun. So F minus, ano ba yung F1? Sabi daw yung drag is 0.04 of the weight. Pare-pareho naman yung tatlong cars, di ba? Each has a mass of 500 kilograms. So that is simply what? 3 times 500 kilograms times 9.8. So this is equivalent to the weight of each car multiplied by 3. Multiplied by the factor. What is the factor given? 0.04. That is the factor, 0.04. And that must equal the total mass. So that is 3 times 500. Each has a mass of 500. So 3 times 500 times the required acceleration of 0.20. So simple lang, no? F is equal to, how much is this? 3 times 0.2 is 0.6. 50 times 6 is 300. Plus, how much is this? 5 times 4 is 20 times 3 is 60. 6, 48. 54, 59.
598 na.
Is it 898? Paki-check na.
Yes po, sir.
Yes. And what is the unit? Newtons. All right. How about the tensions between cars 1 and 2? Car 1 and car 2. So merong cable, right? Car 1, car 2. Call it as tension 1. So meron kang force dito na F. Applying Newton's second law to car 1. Summation of F equal to MA. F minus T1 equal to the mass. M1 times the acceleration. So we know that F is 898 minus T1 equal to mass 500 times 0.20. So T1 is equal to 898 minus 100, and that is 798 newtons. Okay? So for a while, hello, Jobert? Oo. Teka ha, sandali lang ha. Okay. Can still see my screen?
Yes, sir.
Ayan. So T1 is 790.
Yes, sir.
All right. So let us now go to T2, the tension in the cable between cars 2 and 3. So we make the same analysis. No? So let me just connect it here. And this is car 3 and the tension is T2. So let us isolate this one. Okay. So applying Newton's second law to 2. So we isolate car 2. Summation of forces equal to MA. To the right, it is T1 minus to the left, T2. Okay? To the left, T2. Ay, sorry. Okay, I forgot something here. I think I have to change this. Let us go back to car 1. What is wrong about our solution in 1? Can you tell me? Can you tell me what is missing in our formula, in our equation involving car number 1? Okay. So going back to 1, there is a drag. There is a drag of F1 there. Okay. So going back to car 1, applying Newton's second law, we have F minus F1 minus T1 equal to M1A. Okay. We miss this part F1. So F is how much? 898. 898 minus F1. That is 500 times 9.8 times the drag. What is the factor for the tension, for the friction? 0.04 times 0.04 minus T1 equal to the mass 500 times the acceleration of 0.2. Okay, can you give me the value of T1? How much is it? What is T1?
702 po.
Is that T1? Did you subtract 100? You have to transpose negative T1 to the right, so it is positive. So you need to subtract 100 from 898 minus the product of 509.8 and 0.04. So it should be what? 602?
Yes po. I kind
Yes.
of forgot that last part po. Sorry po. I
Okay,
might
so
have
we
made
go now
a
to,
slight calculation error.
we now isolate car 2. So for car 2, what will be our equation? Applying Newton's second law again of summation F equal to MA. So it will be T1 minus, there is friction F2, minus the tension T2 equal to M2 times A. So T1 is 602 minus the frictional force is 500 times 9.8 times 0.04 minus T2 equal to mass 2, 500. Again, the acceleration is 0.2. So that gives us T2 equal to
306, sir.
306 po.
306 newtons, yes. All right. Any questions?
None so far po, sir.
Okay, so let us now proceed to Newton's law of gravitation. Let us state Newton's law of gravitation. It says that every particle in the universe attracts every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. By the way, are you recording this?
Yes po, it was
Yes, sir.
recorded. It's been recording since the start po, sir.
So every particle in the universe attracts every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. So if there are two masses, let us denote them as M1 and M2. One exerts a force on the other, equal amount, even if they have different masses. Say that they are separated by a distance r. According to Newton's law of gravitation, that force F is directly proportional to the product of the masses M1, M2, and inversely proportional to the square of the distance between the masses. All right? So, combining these two, F is directly proportional to M1, M2 over R squared. And we convert this into an equation by introducing a proportionality constant G, M1, M2 over R squared. And we refer to G as the gravitational constant. We refer to it as the gravitational constant. Now, the value of G in MKS is 6.67 times 10 to the negative 11 Newton meter squared over kilogram squared. So our masses should be expressed in kilograms, no? M1 and M2 in kilograms and R in meters. So that is our formula in finding the force between two particles of masses and M1 and M2 separated by a distance r. Okay. So there are two masses, M1 and M2, 3 and 8 kilograms respectively, and the distance between them is 20 centimeters. We determine the force that one mass exerts on the other. So this one is M1, the other is M2. 3 kilograms and 8 kilograms. The distance between M1 and M2 is 20 centimeters. So F is equal to G times M1 M2 over R squared. 6.67 times 10 to the negative 11 Newton meter squared over kilogram squared. Times 3 kilograms times 8 kilograms divided by 0.2 meters squared. So we need to convert 20 centimeters into meter. So that is in meters squared. So everything cancels. Units, m squared, kilograms squared. The resulting unit will be in newtons. So how much is that? How much is that? Is it 8 times 10 to the negative 9 newtons?
Yes po, sir.
Okay. So supposing I place a third mass midway between M1 and M2, which is equal to 5 kilograms, what will be the net force on that mass M3? Suppose a third mass, M3 equal to 5 kilograms, is placed midway between M1 and M2. What will be the net force on M2? So, paano na yun? M1, M2. Then we place a third mass somewhere here. Okay. That's the third mass. M1, M3, M2. Between M1 and M3, you have that force F1. Between M2 and M3, you have that force F2. So there are two forces acting on M3. The one exerted by M1 and the other exerted by M2. So to find the net force on M3 is to get the resultant force of F1 and F2. Okay, will you do that? It is placed, M3 is placed midway between M1 and M2. So that means that the distance of M3 from M1 and M2 are both 10 centimeters. So F1, force between M1 and M3. F2 is the force between M2 and M3. Will you provide me the answers? Kindly provide me the answers for F1 and F2.
Sir, sa F1 po, 1 times 10 raised to negative 8, sir.
Negative 8 or negative 7? Will you check?
Sige po, sir, wait lang. Yes po, sir. Negative 7 po, sir.
Okay, how about F2?
Sir, 2.67 times 10 raised to negative 7, sir.
That's correct. 2.67 times 10 to the negative. But mind you, forces are vector quantities, right? So F1. F1 here is in the negative direction. Okay? It is directed to the left. Okay? So the net force on M3 will be equal to negative 1 plus 2.67 times 10 to the negative 7 or 1.67 times 10 to the negative 7 newtons positive, meaning it is directed towards M2. Clear? F1 and F2 are oppositely directed. So to find the resultant is to get the difference. Or algebraically, you add the magnitudes of F1 and F2. Magnitude of F1 is negative. Okay? Is that clear?
Yes po, sir.
Yes po, sir.
So as an exercise, you can work on this. Let us say that there are 3 masses at the vertices of a right triangle. Okay, let me change this. Transfer this to the other side there. Okay. Say M is equal to 100 grams. M1 is 2 kilograms. And M3 is 4 kilograms. 20 centimeters, 20 centimeters. Find the net force on M. Okay? May tanong kayo regarding the problem? So there are 3 masses at the vertices of a right triangle, isosceles right triangle, 20 centimeters by 20 centimeters. These masses are 100 grams, 2 kilograms, and 4 kilograms respectively. We want to find the net force on mass M. So identify nga natin ano bang mga forces dyan. Between M and M1, always attraction, ano? And direction. So you can call it as F1. Between M and M3, attraction din yan. So F2. So you simply get the resultant vector of F1 and F2. Okay? So that is problem 1. Problem 1. Problem 2. Again, 2 masses. Call them as M1 and M2. Given M1 equal to 300 grams and M2 equal to 800 grams. Let us say that the distance between these two is 25 centimeters. Question. At what point between M1 and M2 must a third mass M be placed so that the net force on it, the net force on M is 0. Okay? So at what point between M1 and M2 should the third mass M be placed so that the net force on M is 0? Any questions? Any questions? I think I should post this in Septo. Any questions?
Not that much po, sir.
So we are already in week 15. exercises. Newton's law of gravitation. Okay. Okay, that's it. So are there any questions?
Parang wala naman po, sir.
So let us continue. Let us now go to friction. Welcome to my lecture about friction. Friction is an important force in many aspects of everyday life. Oil in car engine minimizes friction between moving parts. But without friction between the tires and the road, we couldn't drive or put the car in motion. Air drag decreases fuel economy but makes parachutes work. Without friction, nails would pull out. Everybody will crawl on the floor, and even riding a bicycle would be hopeless. When a body moves or tends to move past another body, there is resistance to motion, and this resistance to motion is called friction. Let us consider a box on an apparently smooth horizontal plane. On a microscopic level, friction results from the intermolecular forces between two rough surfaces at points where they come into contact. The actual area of contact is usually much smaller than the total surface area. In other words, frictional force arises from the interaction between molecules at high point on the surfaces of the box and the floor. When you try to slide a heavy box across the floor, the box doesn't move at all unless you push with a certain minimum force. Then the box starts moving, and you can usually keep it moving with less force than you needed to get it started. And this leads us to two important types of friction: static friction and kinetic friction. The type of friction present when the box is not moving in spite of being pushed is static friction. But the moment the box begins to slide, the friction present is kinetic friction. Friction may be classified into sliding friction, fluid friction, or rolling friction. Sliding friction results when one body slides past another body, while in fluid friction, the force resists motion either within the fluid itself or another medium moving through it. The resistance to flow as an object falls down in a column of liquid is termed as viscosity, while rolling friction is involved when a wheel, ball, or cylinder rolls over a surface. What are the undesirable effects of friction? 1. It generates heat. When surfaces are constantly moving past another, heat is generated. It also increases the work. And most undesirable effect of friction is that it causes the wear and tear of the surfaces that are in contact. It causes the wear and tear of the moving parts of a machine. Even the sole of our shoes are worn out because of friction. However, there are also a number of desirable effects of friction. It prevents sliding. Walking is possible because we rely on friction to prevent sliding. It holds things together. Screws and nails hold things together. Pencil for writing. Writing using a pencil is not possible if there is no friction between the paper and the pencil lead. Fan belts. Fan belts and drive belts rely on the friction between the belt and the pulley to transmit power. There are several ways of minimizing the effect of friction. One is to smoothen the surfaces that are in contact. Two, we use oil or lubricants. Three, streamlining is one way of reducing air resistance and fluid resistance as well, and converting to rolling friction. In converting to rolling friction, we use either a wheel, a roller, or a bearing. What are the additional facts about friction? One, friction depends on the materials that are in contact. Frictional force between wood and steel is different from the frictional force between two wooden materials or two metal surfaces. Once a body moves past another body, no matter what the speed is, the magnitude of the frictional force will remain constant. In other words, friction is independent of speed. All things being equal, the friction present when the broader side of, say, a block is moved past another surface will be the same as when the narrower side of the block is made to move past the same surface. Or, simply put, friction is independent of the contact surface area. Friction is in the direction that opposes motion or attempted motion of the systems relative to each other. Frictional force always opposes the direction or attempted direction of motion. Friction is parallel to the contact surface. Sliding friction is always parallel to the surfaces that are in contact. And lastly, the frictional force is directly proportional to the normal force that presses the two surfaces together, or the magnitude of the frictional force is dependent on the force pressing the surfaces against each other. As soon as sliding starts, the frictional force usually decreases as it is easier to keep the box moving than to start moving it. Since the box is already sliding, the frictional force in operation is the kinetic frictional force. This diagram illustrates how the static frictional force is building up during the period that the box or the block remains at rest. As the applied force reaches the maximum static frictional force, the kinetic friction starts to play and decreases and normalizes to a lesser magnitude than the maximum static friction. There are some situations, however, where the surfaces in contact will alternately stick and slip, meaning static friction and kinetic friction will alternately play. Example is the squeak made by a chalk held at the wrong angle while writing on the blackboard. Another is the squeaky noise that the wiper blades of the car make when the glass is nearly dry. Still another is the shriek of tires sliding on asphalt pavement. Here is the table of values of the static and kinetic coefficient of friction for various systems or surfaces that are in contact. Rubber on dry concrete, the coefficient of static friction is 1 and the kinetic friction is 0.7. Now, steel on steel, dry. Static friction is 0.6, kinetic friction 0.3. Shoes on ice, the coefficient of static friction is 0.1 and the coefficient of kinetic friction is 0.05. And for ice on ice, the static frictional coefficient is 0.1 and for kinetic friction, it is 0.03. Okay, are there any questions? So we know that friction opposes motion, and as such, it will always be opposite to the direction or intended direction of motion. So okay. So the force that presses the two surfaces in contact is known as the normal force. And this normal force is equivalent to the weight of the block. In this case, the block is on a horizontal plane. It is the weight of the block that presses it against the horizontal floor. And the reaction of the floor is the normal force. So since there's,
Sir, may
yes,
presentation po.
why? Wala akong sound?
Presentation po, sir.
For a while. Can you see my screen now?
Yes, sir.
Okay.
Yes, sir.
So
Yes
since
po, sir.
there is no friction involved, no? If we are going to apply a force F, the tendency for the block is to move to the right. But since the force applied is not enough to counter the force exerted by the floor on the block stays at rest. Huh? So the force, the frictional force here is equal to the applied force. And that frictional force involved is static frictional force. So if there is no motion, the friction that is present is static. Once it starts to move, it will be the kinetic friction that will be present between the two surfaces that are in contact. And it says that the frictional force is directly proportional to the normal force. So the greater the normal force, the greater the frictional force. So kung mag-apply ka ng additional force F dito, no? The static frictional force will be greater. Why? Because the normal force is increased. So the greater the normal force, the greater the frictional force. And of course, this is equivalent to F equal to the coefficient of friction and that coefficient of friction is the static frictional force. The static frictional force could be any magnitude less than or equal to mu s times n. No? Because as we have seen in the presentation, the static frictional force is slowly building up. No? As you increase the applied force, the static frictional force increases. But once the applied force is equal to the maximum static frictional force, then the block will begin to slide. It will begin to move. And henceforth, the friction that will be present is kinetic friction. Are there any questions? So the formula is simply F equal to mu n. If it is kinetic, the coefficient of kinetic friction is equal to mu sub k times n. Is that clear? For a while. Okay. For the given figure, you have a 10 kilogram block on a horizontal plane where the coefficient of friction, static friction, is 0.4. Applying a force of 30 newtons parallel to the plane on the block, what will be the coefficient of static friction? What is the coefficient of static friction? Okay, what is the maximum value for the static friction? It is equal to mu times n. No? The coefficient of friction, coefficient of static friction times the normal force. What is the normal force in this case? The normal force N will be equal to the weight W of the block. So if you just take the summation of forces Y, 0, N is equal to W. N is equal to 10 times 9.8, and that is 98 newtons. All right? So the maximum static force will be equal to 0.4 times 98. And how much is that? That will be 39.2 newtons maximum. Since the applied force is only 30 newtons, it is well within, or it is well less than the maximum static frictional force. Then the frictional force, static frictional force present here, if we are to take the summation of forces along X, will be equal to that applied force of 30 newtons. So F minus Fs equal to 0. So your Fs, or your F is equal, your Fs rather, is equal to F, which is 30 newtons. Question? So ibig sabihin, na hindi pa rin gagalaw yung block even if you apply a force of 30 newtons. Kasi mas mababa siya doon sa maximum static frictional force of 39.2. So supposing that the applied force F, no, say the applied force F is equal to 40 newtons. What will be the kinetic frictional force given that the coefficient of kinetic friction is 0.3? Anyone? Since the applied force of 40 newtons is greater than the maximum static force, 39.2, therefore, the type of friction present will be kinetic friction, meaning there is motion already between, or the block will move past the horizontal plane. So it is the coefficient of kinetic friction that we are going to use. And so, the kinetic frictional force will be equal to mu times n, kinetic, 0.3 times the same normal force of 98 newtons, that will be 29.4 newtons. So that is the kinetic friction when you apply a force of 40 newtons. And what do you see here? The applied force of 40 newtons is greater than the kinetic friction of 29.4. So what will happen? What will happen? Anong mangyayari? Huh? Yung applied force na F, mas mataas, no? Doon sa kinetic frictional force. So anong mangyayari?
Gagalaw na po sir yung block.
Yes,
Gagalaw
gagalaw
ng-
nga, kaya nga kinetic eh. Aside from that, ano pa?
It's gonna slide ng konti po, sir.
Talagang mag-slide siya, talagang gagalaw siya. Ano pa? Yung applied force mo, 40 newtons, mas malaki doon sa kinetic friction na alam natin na gagalaw. Aside from that, ano pa? Ano pang masasabi niyo tungkol doon sa motion ng block? Have you forgotten about Newton's second law? There will be an unbalanced
It
force
will-
involved, and there will be an acceleration. So by Newton's second law, there will be an acceleration. So summation of forces equal to MA. Summation of forces equal to MA. So the force to the right is 40 newtons minus the frictional force. And the frictional force is 29.4. No? This is the applied force minus the frictional force, equal to the mass 10 times the acceleration A. So the acceleration here will be 10.6 divided by 10. That will be 1.06 meters per second squared. Okay? So dahil magkakaroon ng net unbalanced force, ang pwede lang i-provide na frictional force 29.4. Ang applied force mo 40 newtons, malaki. So merong resultant force. At kapag ka may resultant force according to Newton, there will be an acceleration. Any questions? So I'll be uploading additional lectures about friction in Septo. Pati na rin exercises and activities. Okay? So any questions? Any questions? Or you want some more problem? So you can try this. No? Okay, find F here. Find the force F that will impend motion. So motion impends. Meaning to say, you will be using the maximum static frictional force. So what will be the force F that will impend motion on the block, given the weight to be 100 newtons? Okay, so you try and work on this. Any questions? You have to look for the normal force. That is the normal force. The weight will be resolved into Wx and Wy. So what will be the normal force here? What will be the normal force? Can you tell me? Ito yung x-axis natin. Okay. Ito yung y. So meron kang normal force. Where is that? This is your normal force. You have the y component of the weight and the x component as well. By the way, what is this angle? This is also equal to 30 degrees. So how do we determine the normal force? We take the summation of forces along y0. What will be our equation for the summation of forces along y? Can you tell me? Going up minus going down. Force positive y and force negative y. Anyone? Okay, going up is the normal force minus the opposing Wy. And there's still another one. What is that? What is that? It's this one, Fy. So we resolve F into Fx and Fy. Fy will be in the negative y direction. So you still have here Fy equal to 0. That will be your equation to find N. What will be the direction of the frictional force? If motion impends going up, then the frictional force, of course, will be in the downward direction. So if you take summation of forces along x equals 0, it will be Fx minus Wx, no? The component of the weight in the negative x direction, as well as the frictional force F equal to 0. So from this, you'll be able to solve for the force F. I've already provided you all the equations involved. It's just a matter of substituting the values. So any questions? Siguro sama ko na rin ito sa exercise natin. May tanong ba? May tanong ba? So, Newton's law of gravitation and friction. Any questions?
Sir?
None pa, sir. No.
Ay, sir, may tanong lang po ako.
Ano?
Kasi ano po, sir? Kasi, di ba yung example, yung exercise po natin ngayon, ano, medyo similar na rin po siya sa ibang exercise na ginawa namin po dati. Ano po, ask ko lang po, bakit po sa dati pong mga problems po natin, parang wala po tayong ginamit na FY po, sir, pero ngayon meron na po.
Anong FY? Eh kasi nga, depende sa problem. Merong component kasi yung F along the y-axis. Examine mo yung mga F mo. Kasi yung F mo, dati, along X. May component yung F mo along the y-axis. So, nakakadagdag din siya. Nakaka-contribute din siya doon sa normal force. Kita mo to? O, balik doon sa ano. Ayan. Kita mo yung F niya? Nakikita mo ba yung F niya dito sa problem natin?
Yes po, sir.
Oh. Meron siyang, 'di ba parallel siya? Parallel siya doon sa horizontal siya. Yung F mo horizontal. Dati yung F mo kasi along X. Kaya walang component along Y yung F mo. Eh ngayon kasi angulated siya. It is acting 30 degrees about the x-axis. So meron siyang component na Fy at saka Fx. Kaya yung Fy mo nakaka-contribute din para doon sa normal force. Kuha mo?
Yes po, sir. Yes po.
Okay. Any more?
Thank you po, sir.
Any more? So if there are
None po
no
sa akin po.
Okay, so if there are no more questions, that will be all for today. Again, keep on checking your SEPTA. Thank you.
Thank you po, sir.
Bye po, sir. Thank you po.